Hello everyone. Today I'll be presenting on Project 5, Pipe Supports Verifying the Divergence Theorem. I'm Boshaga, and I picked pipe supports because it is pretty interesting. You have a two-part system where the top is the saddle and you have a stand. And the way it works is you would take the pipes and you put on top of that, and this is a pretty common structure out in the field. So it'll be interesting to model it. Here's another picture to show you for scale and to set up the presentation for today. You can see that this is how it looks like, and you would take the pipes and kind of put it on top of the saddle here. And these are some of the values that I'm using to model. So that's the inner pipe radius, the thickness, the weights, and so on. So that's how I'm parametrizing my model. Now let's go ahead to this week's code, some of the interesting parts. So here I'm just showing that this is how the model is being drawn on MATLAB. And I'm going to go ahead and go to the next slide and pull up MATLAB to explain here for a second. So this is this week's code. And here you can see that I am defining my two parts, right? So this is the part one, the saddle, and this is part two for the stand. And the interesting bit is for the divergence and the vector fields. What I'm doing here is I am defining, I'm using a cosine function to give me a nice curve and to also make the answer not trivial. And also this is going to be my skew term over here that I'm using to introduce the skew when I differentiate with respect to x3. Similarly, for my part two, here's where I'm including it. And you can see I'm actually including the same vector field, but I'm writing it in a different way, right? I'm using theta, y, and h here, but for part one, I'm using my s, theta, and y, just because the way that I've modeled or parametrized my structure. I'm going to go ahead and run this to show you that yes, it indeed runs. Okay, perfect. And this is my figures. Figure 1 just shows you the parameterization, figure 2 shows you the scalar field, and figure 3 shows you the vector field. You can see that the volume of the body is 33.39, and my div v integrated over volume of body is negative 3.3392, and the total flux is again negative 3.3392. Let's go back to the slides, and I'm just going to verify that yes, I went ahead and so this is just the same code to show you that it can run on MATLAB. And here's my hand calc, so I'm going to go ahead and make it full screen there to show you that I went ahead and performed the integral. And there was a lot of steps going through this, but I assure you, if you go down this rabbit hole, yes, you end up with the same answer. That's the 33.39, and you multiply that with the negative 0.1, so you get 3.3391, and that matches what it is on MATLAB. Thank you.